OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100 plus active projects, and new project applications are submitted weekly. Projects are open source and are built by our community of volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections. And recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Awesome. Well, thanks everyone for coming. We got a great talk today from David on cloud security and IAM for developers and DevOps. Before I introduce David, just want to run through a quick forward. First off, big thanks to the chapter board of directors who make these meetings happen. Big thanks there. And definitely encourage everyone to connect with us, take a look at our meetup, LinkedIn. The recording for this talk will be posted on our YouTube. I think we've had a couple individuals asking for it. So please take a look there. We've got a lot of great pre-recorded talks there as well. And then OWASP 20th anniversary celebration just happened, September 24th. Also some great recordings from some great presenters. So I recommend everyone go to that link, 20th-anniversary.owasp.org, and take a look. And if anyone is interested in sponsorship with OWASP LA, you can contact us at sponsorship@owasp.org. And we'll add logo, marketing write-up to our meetup site, as well as company name. And that'll go out to our participant list of 2,300 plus now member mailing list. We don't have a speaker lined up just yet for January, but stay tuned on the meetup, and even more reason to subscribe so you can see who's going to be up next. And great. Well, without further ado, I want to introduce David Hendri. David, he has 15 years of experience in delivering enterprise software and leading development teams, and has a heavy focus on cloud security and infrastructure, definitely in the last 6 years. He's co-founded Solvo in 2020, and he was one of the first R&D employees at Dome 9 Security, which was acquired by Checkpoint, where he was leading key features and helping users uphold compliance in the cloud. And then Dave is also a graduate of NAMRAM, hopefully I said that right, which is an elite military programming training, which sounds incredible. So, but yeah, thanks for coming, and thanks for joining us across some time zones here. So I can hand it over to you.
So thank you very much for the introduction, and thank you for having me here today. And let me share my deck. Okay, so today we are going to talk about cloud security, IAM, and tools for developers and DevOps. So I'll tell you a little bit about my background and my relation to this topic. We'll discuss the evolution of enterprise systems when it was on-prem and how it evolved into the cloud environment we know today. We talk about cloud managed services and why do we use them. What is IAM? And I'll tell you a story that illustrates why understanding IAM is so important. And we'll do a live demo to demonstrate how IAM misconfiguration can be exploited and what are some of the risks. And we'll end up with how we can protect ourselves. So first, hi everyone. I'm David, the CTO of Solvo. I have over 15 years experience in software development. I've been in the cloud security domain for the past 6 years, and in the year and a half ago, I co-founded Solvo with Shira Shamban, which is also a co-chair in OWASP Israel. And she's the CEO of Solvo, I'm the CTO. In Solvo, we are developing tools that helps developers and DevOps to automate cloud security. Okay, so first, back in the on-prem days, when you had your data center in your basement, and let's say you needed to launch a new SQL server, so you went to the IT team and asked for a new resource. After understanding the requirements, IT could add the required resource in the right network zone and configure the corresponding firewall rules. This process was obviously more time-consuming and limiting, but hands-on and relatively secure. Nowadays, as you can see, the environment looks completely different. You probably have your awesome CI/CD pipeline that utilize tools like Terraform, CloudFormation, or other infrastructure as code tools to create infrastructure. So you don't need to ask anyone to provision infrastructure for you. You can do it by yourself. And this has implications. We'll talk about it later in this session. So the cloud environment looks very different. Since it is very easy to create your own infrastructure with a lot of freedom and huge variety of options, it usually contains a lot more nano or microservices that interact with each other. These micro nano services can be a Docker container orchestrated by Kubernetes or EKS, which is the AWS managed version of Kubernetes. Or it can be a container running in ECS, which is AWS proprietary container orchestrator. Or it could be a cloud function that runs your code. In AWS, it's called the Lambda function. Later in the demo, I'll exploit a Lambda function, so stay tuned. Or it can be other types of applications. These resources can use other services. Some of them are managed services. So what is a managed service? So here in the presentation, I'm showing only these are some of the popular managed services in AWS. For example, S3 is a blob storage. DynamoDB is a document database. SNS is a notification service. It allows you to implement a pub/sub architecture. SQS is a queuing service. Usually SNS and SQS come together and they serve as a message broker platform similar to RabbitMQ. And Kinesis is a stream processing service similar to Kafka. So what is common to all these services? They are fully managed by AWS. It means that you don't need to configure a new environment, instances, network rules. Actually, there are no instances at all, meaning there are instances, but you don't directly manage them. You can't even see them in AWS console. AWS manages these resources behind the scenes to make life easy. So how you can use them? Simply by using AWS API. You can choose your preferable language, programming language, and use AWS SDK to access these services. Here you can see a small portion of a long list of services that AWS continues to add. So I created my first managed service and I can write a simple code to access it, but how exactly I can control who and what else can access it? So in the world of managed services, as you probably guess, firewall rules and network configuration are no longer the answer. It is done by using IAM, which is a short for Identity and Access Management. So in our cloud environment, we have identities that perform actions, which require permissions. Usually when you think of an identity, you imagine a human user, but when you think about it, most of the actions performed in your environment are done by applications, meaning machines. For example, it could be a container reading a data from a database or saving an object to an S3 bucket and so on. So these applications use roles in order to access a resource. So a role consists of a policy, and a policy defines what actions can or cannot be done. So you assign, or more accurately, you attach a policy to a role, and then you assign the role to an application. In this case, the application is an EC2 instance. It can be a Lambda function, a Docker container, whatever workload type you use in order to run your application. And then the application can perform actions on behalf of the role. So this is how applications interact with other managed services. So here you can see an example of an IAM policy. IAM policy is basically a JSON document, which has a version, which is a constant value, and a list of statements. A statement consists usually, because this is the most common way to define a statement, but there are other ways which consist of conditions and other stuff, but this is the most common way. So it consists of an effect field, which specify whether the statement is an allow or deny. And it consists an action field that specify what action can be performed and the resource that this action can be performed on. So in this case, the action is get object, and the resource is an S3 bucket, my confidential data bucket. And notice the asterisk here in the end. This practically means that you can download all objects inside the bucket. If I was specifying here a specific object or specific key, then I could have only download this object and not all of the objects. In this example, the asterisk appears also in the action field. So here, this policy grants all get, list, and put actions on all S3 buckets. So basically, it means that it allows 117 possible actions. That practically means a full access to S3 buckets. So this policy translated into a full access to S3. So why would someone use wildcards? It seems so obvious that you shouldn't give so much permissive permissions. But why using wildcard is a common practice? So first, it's easier. It takes time and knowledge to craft the exact policy, and usually developers don't have this knowledge or time. And also, no one wants the code to be break because of a missing permission. So you start with these wildcards and then the application works. So I leave it that way. I don't want to break it. I'll change it later, and later never comes. Okay, we almost got into the fun part, the live demo, but before that, I want to tell you a real life example that shows why what we are talking about is so important. So Capital One is a big financial corporation. In July 2019, they reported a breach. The breach caused the sensitive data of 100 million users to leak. The cause of the incident was a misconfigured web server with an overly permissive permissions. A smart hacker exploited a vulnerability in that web server that allowed her to run a command on it. The web server was an AWS EC2 instance with an assigned role. The hacker ran a command that retrieved the instance credentials, and by that allowing her to use the assigned IAM role outside of this instance. The IAM role had an overly permissive policy that allowed to access all S3 buckets. So basically, the bucket that was needed to be accessed is just a bucket with a static resources with no sensitive data. And instead of configuring this specific bucket, the permission allowed to retrieve data from all the buckets in the organization. And part of the buckets contained sensitive data. So potentially, if the role had the minimal permissions it needed, even if the hacker committed a breach, the damage wouldn't have been so massive. So it's a common concept in security that security is like an onion, and each layer of security helps to contain risks. And in this case, a minor breach in the first layer left the entire organization compromised. Yeah, so we are getting to the live demo. And before the live demo, do we have any questions so far?
I don't see anything in the chat just yet, so.
Okay.
What about, could you explain a little bit more what your company does?
Yeah, so Solvo helps developers, DevOps, and whoever you use or maintain infrastructure in the cloud to do it in a security manner, meaning we are analyzing the behavior of the application running in your environment, and based on that, we recommend you and enforce the right security policy for your application. So we're getting to the end of the session, but basically, instead of thinking what is the right configuration for your application, Solvo helps the developers to do it instead of them.
And you use AWS?
Excuse me?
And you use AWS, or do you use Azure as well?
So currently we are supporting AWS, but soon we'll have also support for Azure.
What would you say are your like top pros maybe AWS has over Azure?
What the top what?
Like pros, like positives over Azure.
I think the challenges are very similar, because eventually you need to understand what is how the application behaves, and based on that to configure the security permissions. And it is a challenging task both in Azure and in AWS. So it is very similar as I see it. And both of the vendors are trying to help developers to improve their policies, and the policies are improved, but still we still have a long distance to the accurate least privilege policy.
Cool.
Cool.
Hey, thank you so much. My name is Victor. Yeah, it's really interesting. So is your solution more geared towards creating a customized solution? Like if I think about IAM world, I think about SailPoint, I think about Ping, or yeah, Oracle. So is your solution that you develop really a ground up? You see what the company needs, and then from there you create like IAM policies and how you yeah, operate everything. Yeah, I just would like to have a little bit more insight maybe about that.
Yeah, sure. So later in the demo, I'll present how it can be done using Solvo. So maybe we'll start with the live demo, and then I'll show a bit about the product and how it can be done using Solvo. So that's a great question. So let's start the demo. Okay, so what we are going to do, we'll take advantage of a misconfigured S3 bucket to upload a malicious file. The malicious file exploits a vulnerability in the application's code to hijack a Lambda function session. Using the hijacked credentials, we will perform actions on behalf of the role that was assigned to the function. So this is what we are going to do. So let's start. So let me move to the close the deck. Okay, for the sake of the demo, I'll be using this OWASP web application. This is an awesome project called DVSA, which developed by Tal Melamed. And this project allows you to practice security, cloud security principles. This project mimics a web application or an e-commerce site where you can order a video game. And once you ordered a video game, once I complete the order in the site, then I get an email message with a confirmation number and a link to a receipt file. The receipt file is simply a text file, which consists of the order confirmation and some details about the order. So this is the flow that this application implements. So now let's say I'm the bad guy, I'm the hacker, and I want to see what can I do with this information. So first I'll take this link to the receipt file. I'll copy the link address, and this is what the link look like. So immediately I can see that this link targeting an S3 bucket because of the domain pattern. This is the path inside the bucket, but more important is this part in the domain name, which consists of the bucket name. So let me copy this value. And then I'll go to my terminal, and I'll be using AWS CLI. AWS CLI allows me to perform API calls using my terminal. So the first API call I'll try to perform is on S3 service. I'm performing the list objects action, and the bucket on the bucket that I just discovered, I'll execute the command. I'm sorry, just a second. I need to clear my credentials. Okay. So I performed this action. And as I can see, the action completed successfully. And I retrieved content from the S3 bucket. I can see the key. And I can see basically the list of items or objects inside the bucket. So now I can see not only my receipt file, but also others' receipts. Let's try to run another command. This time, I'll try to download the receipt file. And to do so, I'll be using the copy command. I'm copying from a path inside the bucket into a local file. This is what the copy command does. And as I can see, the download completed. And now I can open the file I just downloaded, and I can see that is similar to the one I received, which is an order confirmation of another user. Okay, so up until now, I can explore and download data of other users, which is bad, but let's see how I can take it even a step further. So now, I'm executing this command, get bucket notification configuration. This command retrieves any events or triggers that are configured on this bucket. And as I can see, there is an event that is configured. This event triggered when an object is created, and it triggers or invokes a Lambda function, this Lambda function. And there is a filter that triggers the event only when a raw file is created. So now I know that when a raw file is created, this Lambda function will be invoked. So now let's try to download or sorry, to upload a file and see if I can also upload a file. Sorry. Yeah. Okay. So again, I'm using the copy command, and now I'm trying to upload a file to the bucket. This time the bucket is the target. Now let me run this command in the right path. Okay, so I uploaded this hello world text file, and the operation succeeded. Even I can try to verify it and use again the list objects and see that my file was really uploaded to the bucket. So I can upload an object to the bucket, and I know that if I upload an object with the raw extension, a Lambda will be triggered. So now let's combine the two. And again, upload a file, use the same copy command. But this time, the target is a raw file. But if you can see, the file name is not a legitimate file name. It hides itself a curl command that sends data into an HTTP endpoint. Let me execute this command. Okay, so the file was uploaded. And now let's take a look at my AWS account, a different account than the application. This is my hacker AWS account. This is the endpoint that I used in the curl command. And if I go to the integration, I can see that it saves the data into an SQS queue. So I'll go to the SQS queue, a poll for messages, and as I can see, I received a new message. So let's recap what we did so far. So we started with a misconfigured S3 bucket that allowed me to upload a raw file. And in the raw file, in the file name itself, a call command was embedded. So the file was uploaded to the S3 bucket. Then a Lambda was triggered because we saw that there is an event that is configured on the bucket. So a Lambda was triggered, and the call command was executed because of a vulnerability in the code in the Lambda function. And this vulnerability allowed me to send data into my AWS account using API gateway and SQS. So I have a way to execute commands in this Lambda function. So let's see how I can take advantage of it. So I'll go back to the terminal. And this time, again, I'll upload a raw file. Same command, again, the raw file, same endpoint, but this time the data I'm sending is the environment variables that are defined in the Lambda function. So I'll execute the code again. I'll go back to my SQS queue. Okay, and I received a new message. This time, as you can see, the message is much bigger. And it's base 64 encoded. So let me decode it and share it with you. Okay. So these are the environment variables that are configured or defined in the Lambda function. I already know that this is a Lambda function, this is the name. Now I can see that this is a Python runtime. But more important are these three environment variables: the session token, the access key ID, and the secret access key. So these environment variables are basically the credentials that allows the Lambda to perform actions on behalf of the assigned role. So when the Lambda function perform action or access S3 bucket or DynamoDB table, it uses these credentials in order to perform the action on behalf of the assigned IAM role. So now let me set up these credentials in my machine's profile, and let's see what I can do. Okay, so I configured these credentials. And now let me check or run this command. This uses STS, the Secure Token Service. And this command allows me to retrieve the identity of the credential that I'm using. So after I run this command, I can see that now I'm running as an assumed role, the role that is assigned to the Lambda function. So now every action that I'll perform, I'll perform it on behalf of the assigned role. So now I can explore the AWS account and try to execute commands like using SSM. SSM is a centralized configuration service, and I can describe the parameters inside SSM. I can try, and as I can see, it succeeded. I can see here parameters like MySQL connection string, Salesforce API key, and so on. I can try and run the get parameter, which returns the value of the parameter. And this parameter is a secured string, so it's encrypted. So I can try to decrypt it and see if I have permissions. And as I can see, I have permissions to get the value. Obviously, this is a demo and not a real value, but in a real world, I will be able to get the API key of Salesforce or other services, third parties, and use it. Next, I can try to list all DynamoDB tables and see all the tables in the account. I can try and scan one of the tables and see in this case, the orders of other users and explore the data. I can try and list all the buckets. So we started with a misconfigured S3 bucket that I can explore inside the bucket. And now I have ability to explore other buckets in the account, very similar to the scenario that happened in Capital One. And also, I know that this function sends an email. So the email that we started with, the confirmation email. So I can guess that it uses SES, the email service, to send emails. So I can try and send email, but this time, instead of the do not reply generic email, I can try to impersonate or fake an email from a different user inside the organization. So I can try and ask for a money transfer from the CFO as me pretending to be the CEO or something like that. Also, I can try and use STS again, but this time I'll use the assume role action. Assume role action is the action that allows me to use or get credentials of an IAM role. So this time I can try and enumerate on or common naming conventions of privileged roles like admin, administrator, DevOps. So in this case, I tried admin, and when I execute the command, I can see that I successfully assumed the admin role. So now, basically, I have admin privileges, and I can do whatever I want in this AWS account. So, okay, so let's recap on what we did so far. So we started with a misconfigured S3 bucket that allowed us to upload a file, a malicious file. The malicious file exploited a vulnerability in the application's code to retrieve the Lambda function temporary credentials. We use these temporary credentials to gain access to other AWS services, and eventually we was able to assume an admin role. So this is what we did so far. So why it was possible, and why should we what should we do in order to protect ourselves? So now I'll go back to the web application, and let's see what happens behind the scenes and how this web application moves. So I'm going to the AWS account that this application is hosted in. And this application uses a Lambda function in order to send the email, as we already know. So this is the Lambda function. And we can see this is a Python Lambda function. And let's see the configured permissions of this Lambda function. So this is the IAM role that was assigned to the Lambda function that we just exploited. And this IAM role consists of two policies. One is AWS managed policy, which is called DynamoDB read-only access, which might make sense as this function reads data from DynamoDB. But actually, this policy contains a long list of services, not only full control on DynamoDB, but also permissions to IAM, which is relatively a sensitive service, and also KMS, the key management system that allows you to encrypt and decrypt data in AWS. So this policy is, as we can see, is very broad, and developers use it because it's easy and it's something that AWS offers for users to use. So it sounds legit. In addition, we have an inline policy, which is a policy that a custom policy the developer created. And here, as we already discussed it, this is a very common practice that we see using wildcards. And again, it works. If we just drill down on what exactly this function does. So first, it reads a parameter from an SSM. Then it reads an object from an S3 bucket, the S3 bucket that was misconfigured, that we exploited. Then it reads an item from a DynamoDB table. It combines the two, generates a new file, save it in the bucket, and then sends an email using SES. So this is the flow that the function performs. And now let's see how the policy, how the right policy or the correct least privilege policy look like. So this is the JSON document. I can see that here all the actions are specific. For example, the permission to SSM is specifically to the get parameter and this specific parameter. So now you can't describe and get the Salesforce API key or decrypt it. You won't be able to see it. The permission to S3 was specified to these specific 3 actions on this specific bucket. So now you can't even list the items inside the bucket. Not only list all the buckets, but specifically even this bucket, you can't list the items inside it. The get item, the DynamoDB permission was limited to the get item action and a specific this table. In SES, there is a condition that limits the from address, so you can't impersonate to another user. So as you can see, this is a very, very accurate, and it takes time to build this accurate policy and knowledge. You need to know how to translate a permission to SES, that you need to know this type of condition. and it takes time. So up until now, do we have any questions?
Yeah, I was curious. So when you were sending messages to the AWS account, was that like a separate like threat actors AWS account, or was that did you log into their AWS?
No,
Basically GUI.
that was a different AWS account, just for me to be able to expose a publicly available endpoint to send data to it. So I had my, if I open the example, the diagram. So I had this AWS account, which was where the application was hosted. And I had a different AWS account that was my hacker AWS account, just to be able to receive data from a different AWS account.
And that wouldn't be a little risky at all with it kind of like, creating logs of messages, can you delete that somehow or delete the attacker's AWS account? Do you see what I'm saying?
Yeah, but the data is persisted in my own AWS account that I have only permission. Of course, I can persist it or save it in a non-persistent repository or had some expiration. Yeah, of course. This was only for the sake of the demo. And of course, probably I won't have a direct link to my endpoint. I'll be using a proxy or VPN to hide my IP. But again, for the sake of the demo, this is the overview of the rationale that was implemented. Does that answers your question?
Yeah, I think this is really amazing, like a really great really great illustration of like step by step how the exploitation works. Like, of course, in principle, for me, I mean, I'm just a beginner. How's it in the real world? Like, we've seen Capital One being hacked through such an exploitation, most likely. And how is it with today's world, like companies going to those like SailPoint that I mentioned, trying to exploit it? I mean, is that also very realistic that these services get exploited this way too? Seeing is this specific to AWS, or can these principles be applied to Oracle and SailPoint and maybe Google? How does that look like right now? I mean, of course, we're a little bit smarter now, but just would like to know that as well.
Okay, so that's a great question. So first, as I mentioned, the evolution of enterprise systems moving towards managed services. And when you use managed services, you must, the only way to control access to managed services is by IAM, by these policies and permissions. Each cloud vendor has its own unique language to define permissions, but the concept is very similar to all vendors. So as enterprise systems move towards managed services, so hackers search for these overly permissive policies that eventually that's what grant them the access to these sensitive permissions. So what I demoed here, obviously, is a simple way or a simplified the real world example, but it is based on a real world example. As I mentioned, Capital One, and there are more and more breaches that occurred continuously. Just recently, we had the Ubiquity breach that user used his credentials in order to access the AWS account and encrypt data repositories that he had access. So these breaches happens continuously, and the way to protect ourselves is by configuring a least privilege policies. So even if a breach occurred, the risk will be contained. And of course, the research on behind how to exploit the application, it takes a lot of effort and time. So I just simplified it here.
Yeah, great. Absolutely. So you mentioned least privileged already. So you would also talk about orphaned accounts as well, isn't it? If you have orphaned accounts, if you you have to have like certain policies and procedures in place so that deprovisioning accounts that occurs as well, isn't it?
Yeah, often accounts, often roles. Sometimes companies grant access to a third-party role and they forget about it. And then you realize that you have you tried Datadog 10 months ago and they still have access to your account. So we see it happens all the time. And this is, again, part of the things that we in Solvo helping the organizations to mitigate and minimize the risks. So I would like to show you for a few minutes what exactly we do in Solvo. So, okay. So this is Solvo console. We can see here the types of inventory or workloads you have in your cloud environment. For the sake of the demo, I'll be focusing on Lambda because we just exploited a Lambda function. And here you can see the list of functions you have in your account. Specifically, this function is the function we just hacked, the sent receipt email. And as you can see, each function has its status in Solvo. So first, the status is not connected. After you click connect, Solvo starts to analyze the behavior of the function. And once Solvo has enough data points and can build a suggestion, the status becomes ready for review. And this means that you can open the asset page. You can see, as we already know, the policy was very overly permissive. Here we can see more than 98% of excessive permissions. Only 12 permissions are actually needed for the function to operate properly. And eventually we can get the policy suggestion and get the exact policy that we created manually automatically, which comply with the least privilege model. So here again, the actions are very specific, the resources, the permission to S3 is to a specific path inside the bucket. Even here, Solvo identified that the bucket is encrypted, and in order for the application to be able to use the bucket, a permission to decrypt is needed, but the resource is the specific key that this bucket is encrypted with, not the entire KMS service as the managed policy suggested. And so basically, as I previously described, this is the way we want to empower and help developers and DevOps to do the right thing by suggesting or guide them on the way we think is the right way to configure the application, not only to alert and let the user try to think, what should I do now? Okay, I know that I'm not doing well. What do I need to do now? In addition, recently we launched a new visualization tool called IAM Magnifier, which allows you to visualize in a more human readable way your permissions and IAM configuration. So for example, I want to see who has access or who can upload a file to the same file that we just, the same bucket that we just exploited. And when I click the search, Solvo now builds a complete map of all the permissions and identities, applications, everything that has access to this bucket. You can see it here in the diagram. And you can think of it like a GPS navigator to your cloud assets and IAM. So you can see the routes between an application to a resource or a service. So in this case, I can see that this is the receipt bucket, and I can see that is allowing access to anonymous principal, which means everyone can put an object inside the bucket, as we already exploited it. And also I can see that most of the applications allow full S3 bucket access in order to get to this bucket. So I know that that most of the application, all these sub tree in the graph, grants full S3 bucket access instead of directly allowing the access to this bucket. Also, I can see the function that I just exploited. I can see that it grants full S3 bucket permission. So if we apply the Solvo suggestion, then I will have a direct link to the bucket itself, even a partition inside the bucket and not the entire bucket. So this helps you to understand how your current configuration, what is your current IAM posture. Soon we'll be launching our compliance engine, which allows you to define guardrails on this IAM configuration. So you'll be able to configure alerts when a new asset receives permissions to your sensitive bucket or sensitive DynamoDB table, or when a new admin was born in your account. So we'll be able to get notified by Solvo and perform actions on according to the alerts the Solvo generates. And soon we're launching our S3 bucket suggestion. So similar to what we did in the Lambda, for the Lambda function, we'll have a suggestion for your S3 bucket. So this misconfiguration that we used, the misconfigured bucket in order to upload a file, Solvo will allow you to avoid it by suggesting to limit the bucket policy. So basically, so this is what we are doing in Solvo. Also, we have a complementary report. So you can go to solvo.cloud and simply fill a form and get your free IAM report that highlights high risks in your current configuration. And if you want to hear more, reach out to us.
Awesome. Awesome. Thank you, David. Actually, I had one question too, relating to your demo there as well. I think in your demo, you're exploiting probably an OS command line injection vulnerability, and certainly application security teams I think you demonstrated really well. They have a lot more to think about, not just the code that's executing. As an application security team sort of prioritizing problems to solve, do you think it's better that they start thinking about like, how can we eliminate OS command line injection, or more thinking about like the control plane and AWS and IAM permissions? Curious your thoughts.
So obviously you can't handle everything. So you need to prioritize. This is why we understand that we need to tackle the high risks first. So for example, if you have an overly permissive role that grants actions to a less sensitive service, then I guess you first need to verify that your application don't have any API keys and whatever. But the problem is the common use of wildcard in sensitive services. So I think you must address these issues, because eventually the OS injection, the OS command injection is nothing if you can't have any privilege. And eventually the hacker wants to have a privilege escalation. And in order to have a privilege escalation, you must have an IAM permissions or IAM role user to exploit. And this is why IAM is so sensitive, and you need to invest time to make sure that you are you're doing it right.
Yeah, that's a great point. Defense in depth too, I think makes a lot of sense. Yeah. One other quick question. I was kind of curious with your product. Do you, for teams that have many AWS accounts, does that help correlate IAM permissions between accounts? In your example, you had 2. It might even be that they're moving laterally between accounts in the organization. Is that something that is kind of accounted for or identified as well?
So obviously, when as you connect more and more assets and accounts, then Solvo has more data points, and the recommendation will be more accurate. So from our perspective, it's better to have big and complex and with more and more accounts, because it helps us to build the suggestion better.
Gotcha. Makes sense. Awesome. Any other questions? Feel free to unmute.
Absolutely. I would like to know, what's your ideal client? Like, would you also help clients that are just starting up, and then you build a solution for them, or more clients that have an IAM solution already established, and then you give your recommendation? What's ideal for you? What would be the best scenario, and when is Solvo really ideal to seek your solution?
Okay, so as I mentioned, nowadays everyone use managed services. Even the startup that just exploring AWS, and the enterprise system that perform millions of actions against an S3 bucket. And both of them should care about IAM policies and maintain a least privilege policies. So the developers in both organizations should handle it. And this is why we aim Solvo to help both the small organizations and both the big enterprises, as it's a self-served solution. It's a SaaS solution, but self-served.
Great, thank you very much.
Any other questions?
I kind of have a question geared towards like OWASP too. I was kind of like, I recently got an email about another presentation, and it was highlighting that this presentation would look at OWASP top 10, and it was making the claim that it hasn't changed a lot recently. And I was wondering now with like new, with cloud becoming more and more popular, and it's kind of shifting to that more and more. I was wondering if like, is that kind of a change that is coming, as far as like even what David was saying about you can't do, everything right off the bat, kind of prioritizing certain things. Would that be a change that would be coming to a WASP top 10?
It might be a partial me question too, it sounds like. I thought David was kind of hitting the nail on the head there. And yeah, I think that's also a great question. Yeah, there's kind of the standard OWASP top 10. And I think David might have pointed out there's a serverless OWASP top 10 too. So there are some sublists that have attack vectors that are specific to different technologies that are very, very helpful. I think it's probably kind of hard to, application security can be so huge that the top 10 tends to be like a generalized list and maybe, suited to just the web application. But some of the other more targeted lists really take into account those, additional cloud vectors and sort of these new technologies that are developing. So I definitely recommend looking at those.
Awesome. Yeah, I'm new to the field, and it's a cool organization, and yeah, all positivity all the way around.
Awesome.
Shout out to Arian.
Sounds good. Great. Well, David, thanks again for the time. Thanks for joining us a little bit later as well. Great demo. Fantastic demo.
Thank you. Thank you very much for having me, and thank you for the great questions. And it was very fun for me. Thank
Absolutely.
you.
Sounds good. And thanks everyone for coming. Appreciate it. Have a good one.
Thank you.